I hope you stopped the video. If you haven't, make sure that you did that. We are going to look at where this function is concave up and where this function is concave down. This function is a polynomial function, so we're going to utilize our skills on polynomials, both taking the derivative and then finding when polynomials are equal to 0. We start by taking the first derivative. The first derivative is going to be 1/3 x to the third minus 3x squared minus 16x plus 4. The second derivative is going to be 1x squared minus 6x minus 16. In order to find where this is concave up and where this is concave down, let's find the transition point where the concavity would be exactly equal to 0. In order to do that, we set the second derivative equal to 0. In this case, we have a quadratic function in which we can factor this quadratic polynomial factors into x minus 8 multiplied times x plus 2. The zero factor property says that either x minus 8 is 0 or x plus 2 is 0, which gives us 2 points, one of which is x equals 8 and the other is x equals -2. Now, those 2 points are going to split the number line, the real number line, into 3 different intervals. One from -infinity up to -2. The other from -2 up to 8. And then the other from 8 up to positive infinity. We can assess each one of these intervals separately. Take the interval from -infinity up to -2. Pick out some value in there. I'm going to pick out the value -3. And we're going to plug in -3 into the second derivative. So I plug in -3 into x squared minus 6x plus minus 16. When I did that, I got out a positive 11. And that means along that interval, my original function, the f of x, is concave up. Then I go to my next interval from -2 up to -8. We're going to plug in a value in between -2 and 8. It doesn't matter which one you pick. One of the easiest things to plug in is 0. So I like plugging in a 0 into that. You'll get out a -16. And that means my original function, f of x, was concave down in that subinterval. Lastly, we look at the interval from 8 to positive infinity. Plug in some number between 8 and infinity, or rather plug in some number above 8. I'm going to plug in the number 10 because 10 is above 8 into the second derivative. We end up with 10 squared minus 6 times 10 minus 16. That gave me a positive 24. So my function, I know, is concave up in the interval from 8 to positive infinity. And that tells you where this function is concave up and where this function is concave down.